Here are the 10 aerospace technology trends to watch. 1. Zero-fuel aircraft. Airbus recently revealed 3 concepts for the world's first zero-emission hydrogen commercial aircraft, which could enter service by 2035. These concepts each represent a different approach to achieving zero-emission flight by exploring various technology pathways and aerodynamic configurations in order to support their ambition of pioneering the decarbonization of the entire aviation industry. All of the concepts presented by Airbus rely on hydrogen as a primary power source, an option which they believe holds exceptional promise as a clean aviation fuel and is likely to be a solution for aerospace and many other industries to meet their climate-neutral targets. 2. Structural health monitoring, SHM. Structural health monitoring involves the observation and analysis of a system over time using periodically sampled response measurements to monitor changes to the material and geometric properties of engineering structures, such as bridges, airplanes, and buildings. Aircraft accidents involving catastrophic fatigue failure have the potential for a significant loss of life, which makes innovation in this branch of the aerospace industry so important. The foundation of structural health monitoring is the ability to monitor structures using embedded or attached non-destructive evaluation (NDE) sensors and to utilize the data to assess the state of the structure. Over the last 10 years, researchers have made significant advances in developing NDE sensors for SHM, and they have developed the hardware and software needed for analysis and communication of the SHM results. The NDE SHM sensors that have reached some modest degree of maturing and are able to monitor significantly large areas of structures include fiber optics, active ultrasonics, and passive acoustic emission. Furthermore, low-cost emerging computational hardware, such as graphics processing units, GPUs, is enabling the growing use of advanced physics-based models for improved NDE inspection and for advanced data analysis methods such as machine learning. This is particularly relevant for NASA, for example, as new tools need to be developed in order to support long-duration spaceflight. 3. Advanced materials. Innovative materials can be used in a wide variety of areas, from lighter, more agile aircraft and emerging hypersonic systems to personal protection equipment and anywhere risks or damage can be reduced. Progress in developing advanced materials is expected to address the integration of functions such as energy harvesting, camouflage, structural, and personal health monitoring. For example, graphene is a carbon-based material, which is merely 1 atom thick and can be used to make batteries that are lightweight, durable, and applicable in high-capacity energy storage. Plus, they charge more rapidly than a typical battery. 4. Smart automation and blockchain. The blockchain, which is typically associated with cryptocurrency systems, uses data transparency to enhance security. Public key encryption for record-level data security and greater network resiliency are possible due to no single point of failure. In addition, access rights and entitlement management can be automated, which frees up resources to address other security measures or concerns. How does this work? Instead of significant efforts to move components, equipment, and systems along the value chain, the blockchain can arrange the interchange of internal and external supply chain participants all the way to the end customer. It offers a secure, auditable, traceable, and shareable record across a distributed population too. A consensus between the manufacturing partner and their customer can be rapidly arrived at through a shared blockchain ledger, because this leaves behind a clear and unchangeable history of the design, all changes to it, test results, a certification record for the source of all components, and more. 5. Additive manufacturing, 3D printing. 3D printing, also known as additive manufacturing, has been proven to be an excellent manufacturing solution for producing components and parts that utilize significantly less material than other comparable, traditionally manufactured parts. Since the material can be used to create an item through additive manufacturing, extremely complex geometric shapes can be built that have great strength despite the reduced density in the material used. Reducing weight is paramount to the aerospace technology industry due to increasing performance in areas of speed, capacity, fuel consumption, emissions, and more. This realization is leading the aerospace and defense industry to look for applications of 3D printing in its newest products, from seat frameworks to air ducts. 6. Supersonic flights. Supersonic flight is when an aircraft travels faster than the speed of sound. U.S. airline United has announced plans to buy 15 new supersonic airliners and return supersonic speeds to aviation in the year 2029. Supersonic flights sound familiar? Such passenger flights ended in 2003 when Air France and British Airways retired Concorde. The new Overture aircraft will be produced by a Denver-based company called Boom, which has yet to flight test a supersonic jet. United's deal is conditional on the new aircraft meeting safety standards and noise pollution concerns. 7. More resilient and dynamic A&D supply chains. Lower aircraft demand and restrictions on the movement of people and goods due to the pandemic led to a breakdown of many essential aerospace and defense (A&D) supply chains. This has resulted in an impact on smaller suppliers, especially those with heavy exposure to commercial aerospace and the aftermarket business. In 2021, the industry's focus is likely to shift toward transforming supply chains into more resilient and dynamic networks, which could be done using strategies such as onshoring vertical integration and increased cyber defenses. To further strengthen supply chains, ODMs and suppliers should leverage digital tools, including automating internal processes and streamlining workflows, implementing smart management systems, and using data analytics. In a recent survey conducted by Deloitte, 72% of industry executives said they are investing in supply chain ecosystems to leverage external alliance partners. 8. Utilizing Internet of Things (IoT) to anticipate maintenance issues. Aircraft maintenance and repair companies are widely using Internet of Things technology for predictive maintenance of aircraft parts and equipment. An IoT-based predictive maintenance solution can help to predict potential damage, for example, by collecting data from ultrasonic and vibration sensors attached to the spindle of a CNC machine. Analyzing the collected data helps to identify fragile spindles and tools before they break. IoT technology is used to send critical data from engines, wing flaps, bleed values, and landing gear to technicians for preventive maintenance. This data aids technicians to create maintenance schedules, procure parts, and schedule relevant workers to fix equipment. 9. Artificial intelligence. The aerospace technology industry is also benefiting from artificial intelligence and the use of machine or active learning in research and education. Machine learning offers the ability to gain new insights into materials by employing artificial intelligence to discover new patterns and relations in the data. AI can handle far more complex problems than humans and can run the gambit of thousands of outcomes within moments, compared to how long the human brain takes to process information. 10. Autonomous flight systems. Implementing autonomous technologies has been a growing trend across several industries, and the aerospace industry is no exception. Much of this has been focused on increasing autonomous flights, with the end goal being to launch fully human-free flights. While this may still be several years away, investments and innovation will consistently be geared toward this in the coming years. We might see planes being cut down to just one pilot and subsequently becoming autonomously operated in the coming years. This has already occurred with drones, although this technology will obviously need to be scaled up before it's ready for passenger planes and longer journeys.